right, so let's try to speed up. And we already covered this. We talked about future predictions, we talked about classification, and let's spend some time on this machine learning model. And you can treat this machine learning model as, like similar to our brain. What we do, we memorize a lot of things. When something good happens, we memorize that. Something bad happens, we memorize that. And we store all the patterns, right? You go into a building, you go to a store. First time you will try to figure out where the store is. Do I need to take a left? Do I need to take a right? Do I need to look at the directions? First time you are going to struggle. Second time you probably remember what you did last time. And third time, if you go to the same store, you are not going to look at directions. You would be taking right where you need to take right, even without knowing him, right? You'll be talking to someone on the phone, but you will be taking right. Your brain knows that you have to take right there. Same way, all these information are stored in ML model. So in machine learning, the model is very important. Just like data, right? You give data, you train the model, and the model becomes that storage where you store all the patterns. So that's the model, and we use that model to predict future predictions, right? And like I said, we have to optimize, just like humans, right? You write a machine learning program, it won't be perfect from day one. You have to keep on training. You give more data, train more, so you can optimize and you can get better results as we go, right? And let's think now. Yeah. So this is an interesting slide. Like we have been talking about the smart thermostats and Google search results. It's another machine learning. How many of you use Spotify, YouTube, right? Have you ever wondered how they show you recommendations based on your interest?
How does it know?
How does it know? Like you like a particular type of a genre of a song or a particular type of video. How does it know that you like those kind of videos?
As soon as I log into my TV today, it'll pop up and say there's a new action flick on, or it's going to come. How does it even know?
Like some of you know the answer already. Like we all use Netflix. You go there, and Netflix has lots and lots of movies in their catalog, literally, right? And Spotify has millions of songs in their catalog, but they select maybe 100 for you that's personalized, that they think that you are interested in listening or you are interested in watching, right? That's how they use machine learning a lot, and their technology teams, right? They have programmers, not just traditional programmers, the machine learning programmers, to work on those algorithms. And they do this for millions of users. They don't write machine learning code for 1 or 2 or 100 people. They write machine learning code for millions of people, and they can confidently say, this algorithm is going to work for millions of users, not for one person or 2 person or 100 people, right? So Google, Netflix, you take any bigger companies. Tesla, right? The self-driving car, they use machine learning a lot. And even smaller companies. Do you have any bank accounts? I know you are too young still, but some of you have bank accounts, right? And they can predict how you are going to spend money. If you have credit card, and if you shop using your credit card, they can predict where you are going to shop next. Is it going to be a clothing shop? Is it going to be an electronics shop? So they can predict where you will be spending your money next, and they can also predict fraud, right? Say you lost your credit card. Someone took it and they are trying to use your credit card from some other location. They can prevent that by looking at your past usage pattern. You have been using this credit card in this particular zip code, this particular geolocation, and someone took your credit card and went to a different city, say from Detroit to Chicago, and they try to use that card, and they can see, okay, this is an anomaly. That means normally this person uses the credit card near Detroit area. Now he's trying to use this credit card from Chicago, and they can send an SMS message. Is it really you? Like, I have received those kind of alerts. So that's how machine learning works. And there are lots of other use cases. Maybe you want to talk about some of them?
Yeah, generally even ads. Go on your phone and just browse something one day. Do it twice in a day or 3 days in a row, and then you'll slowly start seeing ads specifically target like clothing. Raja was saying, right? You buy one or two, or you browse one or two hoodies, it will start narrowing it down and saying, okay, he likes blue hoodies, he's a male, he's in this range. It's learned in the background, and we don't even realize all this. We just go and I click it, but in the background there's a lot of data being pulled in, and then it says, okay, next time he logs into, it immediately pops, and that's how it catches the interest of youngsters. It says, oh, and that's when you go to your parents and says, oh no, hoodie is coming, I need to buy it. How did it know? Just because you happen to browse. There are articles that you go and type, for example, I want to learn something about machine learning. Go home today and try a few times in the Google search bar. If there's a book coming up, it will start popping up slowly and saying, hey, there's a book learning. These are small ways companies are using to target people, and behind the scenes, machines are helping them, because humanly, it's like Raja said, it's not possible to process data. For example, aeroplanes. A single flight, I was reading somewhere, they did terabytes of data to some servers, right? Human cannot even begin to imagine that level of data, right? You throw computers at them, with their machine learning, they can predict the flight patterns, which way should go, how much fuel you use, everything comes onto the next chart, and somebody prints it out, verifies that, and says, here you go. That's how much it's being used nowadays, without us even realizing. Food. You order food, pizza 2 days.
Yep.
Third day it sends me ads. Domino's has a sale, Pizza Hut has a sale, or Jets has a sale. Just because I happen to buy something, they are tracking everything and using these algorithms.
True.
Right?
And we touched only a few examples here.
Yeah.
There are lots of.
There are a lot of real examples which lean companies use, which I don't want to get into, but realistically, like our companies and Raja's companies, they're using all these in our businesses today. So everything that we are doing is reaching that point now where humans are becoming sort of lesser involved in computational, where we are pushing machines to do it.
Yeah. Maybe you want to talk about this?
So one of the things that we did is for our robotics, right? One of the things was to use machine learning. This year they introduced machine learning, and Google partnered up with first and said, okay, why don't we introduce machine learning? Okay, give a simple example. Previously, you had these two things in there. Okay, in this year's challenge, you have to pick these up and put it somewhere, right? So I don't need to know. I see an object, I pick it up, right? But in the game, there's a place it gets placed and stuff. This is something one of the kids created as a 3D model, right? Now it has to detect that it's a cone. How does the machine know? It doesn't. It has no idea what that is. Now how are you going to tell it? So Raja recorded videos of this, okay, and put it on a computer and said, this is called a cone. This is a duck. It already had the duck and the thing. It took a cone and said, this is a cone. And taught it, when you see this thing in this shape and this color, this is what you need to do with it. So he ran through, and it took him hours.
Yes.
He uploaded to one of the servers, it ran through overnight. It has a huge algorithm it needs to run. So these are practical applications. It took it, but this is also where Google is helping kids come into AI world now, right? This is just an intro for you guys to start using, because as future grows, you will get more and more into this. We are learning at our age now, you are starting to learn at your age, right? So this is where he took this, fed into a system, and say, okay, run your program, and when I give you this, and his level is, if I show you this, you should be accurately able to tell me it's a cone. and you should be able to pick it up, right? It takes time. For a human, if I show you once, you can next day come and I put a cone for you, like I said. If I put a red cone, you'll say it's a cone, right? A model is not like that. So we took that, he used something called tensor models. We don't want to get into too much of those things. What a data set, he took a different visuals of it, put it and say, any angle I show you, because our robot, this robot of ours, can be looking at it from any side, right? As far as it looks and recognizes it, it can use it. And he used that to run through, he compiled a small program, he took the program and put it on this computer, on this robot. Once it sees it, it recognizes it, it picks it up. There's a camera involved, there's a little bit more, but we don't want to bore you with the details, but that's what practically we are using, right? So this year starting, if I'm not wrong, last year Vishy was, I think we were there, but this year is where they opened it for all the kids and say, start using it. And I think it'll mature more and you'll get more and more involved into it and learn more and more of this.
Yeah, this is very similar to self-driving cars stopping at a stop signal, right? Replace the green cone with a traffic light, red light, and replace that robot with your Tesla or any self-driving car. So how does it stop when it's red? Because of all the steps that the machine learning programmers done, like they have fed. If you see traffic like red, you have to stop. So they have trained that machine learning concepts into that computer that's part of the car. So you don't have to tell the car to stop it. It knows when to stop, it knows when to start because of all these things that they have done.
One other thing Raja did before we go there is this pieces of it. He created a video, and there are frames in a video, right? Like every shot comes with 30 frames, for example. He labeled 1, 10, 11, and then told, okay, I told you basic stuff, you now make up the other stuff. I'm not going to label every single piece because it's tedious for him. So he said, if there are 10,000 frames, he's not labeling every 10. He said 1, 10, 15, 30. It then picked it up and said, okay, Raja told me 110, so the next one's also I'm going to put it out. So whichever way you give it, now it knows. It learned from it, from his basic input and said, okay, good, I know what it is now, go for it.
Yeah. So once we have that model, the trained model, we use the trained model in our program over there, and that program is, fed into the robot. Robot sees the object through the camera, and it knows, oh, there is a green cone, I have to go and pick it up. Right, so let's quickly spend some time on Scratch.
Just to get an idea of what Scratch is, and I listed the website. It's a very good tool for you to create programs, okay? It's basically a coding language with a simple interface, right? And I'll show you that. You don't need to know any language to write these programs. All it's the drag and drop, right? You drag, you drop, and you do it. And then it creates a code in the background to run that program, okay? That is how Scratch looks like. I'm sure all of you are familiar with it. This is a very good website for you guys to start learning machine learning. I'll go to the website in a second, but just to get an idea, like that's a very good website for you guys to try out machine learning, to play with it, to see how it functions and stuff like that. There are very simple projects in there for machine learning. It has a very clear-cut step-by-step instructions of what you need to do. Literally, like it tells you, go here, do this, go here. It's that simple. For anybody who's starting, you can literally create it within half an hour, 45 minutes, just to get a feel of it, and then it's up to you how you want to play with it. It's completely free to use and do it, so you can go home and try after you're done with thing here, okay? I just happened to pick up two projects, like the emoji one where I created a video filter and say, as I move my face in the camera, it's going to cover my face, right? And the second one is like, it has two virtual devices, in this case a fan and a light, and I tell it with the commands and say, okay, run a fan. So as imagine there's a fan, I want to do it, which is what we do in Alexa, right? At home, what do? I am ready to go to bed, I don't want to get up and switch off the fan. I said, Alexa, switch it off. How does it know? I could be speaking in a different way and he could be speaking in a different way, but it still switches off the fan or the light or whatever device you want to, right? So let's try that.
Ravi, let's quickly talk about that emoji mask. So this may look like a very simple project, but you guys know Instagram, right? Instagram, you know about filters? Now how does it work? Machine learning. He's going to use emoji as the mask, and Instagram, since they are a bigger company, they have millions and millions, and they have created some cool filters. It's all machine learning. So you are going to see the basics of that filtering on Instagram through this, like how you can create filters. So pull up a chair.
So you can see this, right? This is all it took. This is all it took for me. And all I did is, and there's step-by-step instructions. I just pulled up a project and said, I'm going to try this project. There were literally step-by-step instructions of PDF. And you guys know this scratch, drag, drop, right? So just to play around with it, right? Hopefully the camera working. Yeah, I think it is. Hopefully they're not blocked it here, so. Yeah, I did.
Do we need to refresh the page, maybe? or-
Probably. I need to refresh the page. Let's see. Let me load it. There we go. Give it a second so it starts to pick up. See? I'm moving my face. And it's trying to cover my face, because what I did, I said, whenever somebody is moving his face in front of it, cover his face, right? I can make this bigger, like see, I made it smaller, right? Now, the question is, how does it know? All it's saying is the left eye knows, right? How does it know what his face is? His face is different than mine. If he sits, it'll still pick it up. You kids come here and try, it'll still pick it up. Each of us look differently. How did it do that? Because somebody took about 35,000 more faces and trained a model behind the scenes and says, when you look at some of this structure, you can pick up a nose, you can pick up a left eye, you can pick up a right eye. All I did is I said, okay, left eye. I said nose. I didn't tell what a nose is. I literally did not. I took like 20 minutes to create this program. I literally took from here, everything is there, drag, drop, drag, drop. Behind the scenes, it created a code, it went to its own algorithm and said, okay, when I'm seeing something similar, I can identify it.
It basically predicted the face. And it knows there is a face on the screen, so I'm going to place that emoji on top of it. So there's machine learning concepts behind this small program.
Okay, this is another program. Okay, so this is another program. These are the smart classroom one that I was talking about, right? These are like fans and lights we use all in our home, right? So previously, there are different type of machine learning. One is text-based, where you type or tell and it recognizes the, like when you call today's phones, like you can say, I say yes in a certain way, I say yeah in a certain way, but it still recognizes the text pattern, it's able to pick it up, right? Right now, I took another one from a project here, and I'm going to run that, right? So see what happens. I just said turn on the fan. It picked it up, right? But look at the difference. I said fan off. It doesn't know what a fan off is. Unless I specifically tell it turn off the fan, it knows exactly that piece. But that's not good for me, right? I don't know, he says in the fan off, he says off. I say, I'm not going to repeat the whole sentences. Now this also is machine learning what it's doing, but it's very limited in what it's doing. Now I need to expand this. Okay, how do I train it, right?
So this is the traditional programming. Like before machine learning, we used to tell computer exactly what to do.
So what I ended up doing is, this is what I did. I said, okay, let me try something else. I want it to recognize any way I say it, right? I don't want to always say turn on the fan 4 words. I just want to say fan off, whatever. So I created a basic structure here. And all this is there in that website, by the way. You guys can play around free of cost, play with it, get a hang of it, and it's very, very simple. And you can do cool things with it. Maybe write a program to your homework, I don't know. Awesome. But don't do that, but I'll get paid for it. But so what I did is, I went in here and said, for a fan on, I want more phrases. I said, on fan, fan on, turn fan on, please turn fan on. You could give it more data. Like the more you give, the better it becomes at learning, right? Then it can distinguish the patterns of the words. As far as it sees a fan and an on, it knows, okay, fine. All he means by this, fan on, fan off. I did for all of them like that, right? So I did that. Then, in the same website, there is something called test and learn. It's taking that data, what I gave it, and learning from it. So it just said, fine, you gave me the data, I learned from it. Now it's saying, do you want to test the data? I said, fan on. That's exactly the words I told it I wanted, right? It looks at it and says, with 100% confidence, I can execute this command. Because it's exactly matching what I told. But I don't want to do that. Maybe when I'm typing, I'll do this. O-N-N. That's wrong syntactically. But look what it does. It still is able to detect with 82% confidence and say, I can still work on it, right? I can do on. It's reducing a little bit. Now watch what happens. The confidence level has gone down to 11% from 86, right? This is where if I had given all this combination of, it would have been like, with 80% I can still do what. So if I'm sitting and I'm trying to type something and before night I'm too tired, I'm like F-A-N-N, I'm not looking at every time. Enter, it can still execute the commands. And then this is where you actually go and make that project and do it. I hopefully have that on. Okay, here. So I use those commands to create this structure. I initially created everything, so in the interest of time. Now let's try something. Fan on. Previously did not know what a fan on meant. Lamp on. So that's where machine learning is kicking in the background. It took it like what, 5 seconds? Now if I use this program at home, you can connect to anything and before going to bed I say fan on, turn off, fan on, whatever you want to say or however the pronunciation of the fan is, still it will pick it up, right?
Yeah, and this is the concept behind Alexa and Google Assistant. Like, if you use any of those personal assistants, this is the basic concept behind those popular virtual assistants. And they all use machine learning.